Let's look at another example of where a function might be increasing or decreasing, and let's find some relative extrema. This time we'll use a function that involves trig. So we have 1/2 x minus sine x. We're going to restrict it to 0 to 2 pi. So how do we start the problem? Well, once again, we always need to find the derivative, right, first. So here we go. The first derivative is simply 1/2 minus cosine of x, right? So step 2, find the critical values. Where is the derivative 0 or undefined? Now in this case, this derivative is not going to be undefined anywhere, so we don't have to worry about that. So really it just comes down to where is 1/2 minus cosine of x equal to 0. So in other words, right, where is 1/2 equal to cosine of x? And now we have to think unit circle, right? So where in between 0 and 2 pi is cosine equal to 1/2? And that would be in two places, right? Quadrant 1, quadrant 4. So we have critical values at really the 60-degree mark, which would be pi over 3 in the first quadrant, or the 300-degree mark in the fourth quadrant, which would be 5 pi over 3. So step 3, now we need to test, right, around the intervals around the critical values. And remember, we are going to restrict it, right? So we're going to restrict this thing from 0 to 2 pi, right? We only have two critical values to worry about here, so pi over 3 and 5 pi over 3, right? And now we think about what values we can substitute into, remember, the derivative, not the original function. So let's think about what's between 300 and 360. Well, 315 would work, right? So if we took something like 7 pi over 4, right? Substituted that back into the derivative right here, right? Well, cosine of 7 pi over 4, that would be radical 2 over 2, right? So if you think about it, if you have 1/2 minus radical 2 over 2, right? Now the same denominator is 1 minus radical 2, that actually would yield a negative number, right? So overall, this interval derivative is negative. What does that mean? Function's decreasing, right? Now let's take a number between pi over 3 and 5 pi over 3. I like pi here, really simple. You could use other things, but if we use pi, it's very easy to work with. Cosine of pi is -1. So think about that, right? So 1/2 minus -1, that actually yields a positive number, right? So the derivative here is positive, which means f is increasing, right? And then lastly, if we pick something between 0 and pi over 3, we don't have many options, but again, we can go back to pi over 4. So we're going to get really the exact same result as we did in this interval. So the derivative is going to be negative, function will be decreasing. So let's put it all together with our conclusion, right? F is increasing only from pi over 3 to 5 pi over 3, decreasing, right, 0 to pi over 3. Remember, we're not going to say negative infinity, we're restricting this function, 0 to 2 pi, right? And then again from 5 pi over 3 to 2 pi, right? What else do we know? Well, we know that since the function went from decreasing to increasing, it must have a relative min at pi over 3, right? So relative min at x equals pi over 3. And that means it must have a relative max, right, at 5 pi over 3, because that's where the function goes from increasing to decreasing, right? So the beautiful thing about this is, yes, this is all analytical, but don't forget you could always verify this looking at a graph, right? So if you were to graph this function, 1/2 x minus sine x, restrict the domain, you should see everything that we came up with here show up on the graph. Thanks for watching.